All right, kiddos, let's do this. Graphing linear inequalities. Let's sketch the graph of each linear inequality. All right. Notice this is y equals mx plus b. So you have a y-intercept of 4. And then notice your slope is negative 3. So down 3 over 1. Down 3 over 1. This is a solid line, and it's solid because there's an equal to underneath the inequality. So solid. Okay, and because you're in slope-intercept form, you can look at the inequality and it'll tell you the graph. So notice how it's a greater than. This is always only when you're in y equals mx plus b, right? So see how it's y is greater than? So, pardon me. All these values are greater than the line. So that's the side I would shade. You could also do a test point. So let's say you wanted your test point to be 0, 0, right there. Put in 0 for y. Put in 0 for x. Simplify. That is false. So because that's false, that means that's not a solution. That means nothing on this side of the line is a solution. So the other side must be the solution. The line separates the solutions from the non-solutions. Woo! This has a y-intercept of negative 5. And then a slope of up 3 over 5. Just like that. That is going to be a solid line because there's an equal to underneath. If you have this or this, the line is solid. And so we have one of those. So we solid. Okay, now again, you can look at it and see which way to shade, or you can do a test point. So if you do a test point of 0, 0, right there, let y be 0, let x be 0, 0 less than or equal to negative 5. That is false. So that means that was not true. So that means none of these ordered pairs will make it true. So all of these will. So one side of the line is always the solutions. This is slope-intercept form. Y-intercept negative 5. Down 1 over 1 is your slope. Okay, let's draw our solid line. Notice now if it's this or this, sorry, not solid. The line is dashed. Okay, so let's draw our dashed line. My ruler's stuck. I can't get my ruler. Okay, I got another one. Okay, draw your dashed line. That tells the reader that the ordered pairs on the line are not valid solutions. Okay, now I'm going to do a test point. I'm going to use 0, 0. 0 greater than opposite 0 minus 5. That is false. 0 is not greater than negative 5, so that's false. So all of these are true. Woo! This is a horizontal line. So go where y equals negative 4. And this is going to be a dashed line through negative 4. Notice how there's no x value, so x is a meaningless part of this solution, this equation. Notice how it says graph the y values that are greater than negative 4. Well, all of these y values are greater than negative 4. So we graph that. Done! Moving on. Y-intercept negative 5. Slope up 2 over 1. Draw your dashed line, because there's no equal to underneath. It's a dashed. It's a dashed. There's your dashed line. Bada bing, bada boom. Let's do a test point. 0, 0 is the easiest one to use. You can use any point as long as it's not on the line. So 0, 0 is a valid point. 0 greater than 2 times 0 minus 5. 0 greater than negative 5. Hey, that's true. 0 is greater than negative 5, so this was true. So that means everything on that side will also be true. Woo! So y-intercept of positive 2. Up 7 over 4. I had to approximate that. I could go down 7 and then over 4 in this direction as well. That would get me on the line 2. This is a solid line because there's an equal to underneath that inequality. Test point. I'm going to use 0, 0 because it's just the easiest one to use. You could use any point you want as long as it's not on the line. You can use any point you want. But 0, 0 is such an easy point to use. So I let y be 0, let x be 0. 0 greater than 2. That's false. So that means you shade the other side because that was an untrue statement. Woo! That wasn't bad. That wasn't bad. Moving on. Okay. This is a vertical line. Go where x is negative 5. Notice how there's no equal to underneath. So this is a dashed line. Dashed line. Notice how it says x is less than negative 5. Well, that number is less than negative 5. So you shade over there. Woo, that's it. Let's go here. Y-intercept of negative 4. Slope of up 4 over 3. Draw your solid line because there's an equal to underneath. It is solid. Do a test point. Test point is going to be 0, 0. So I'm going to let y be 0. Let x be 0. 0 less than negative 4. That's false. So that means this was false. So that means these are true. Okay. Oh, this is standard form. X-intercept is 10 divided by 3. That's 3 1/3. About there. The y-intercept is 10 divided by negative 2. That's negative 5. There is no equal to underneath that inequality. So I'm going to do a dashed line. Like so. Now I'm going to do a test point of 0, 0. Alright, so let's put in 0, 0. 3 times 0 minus 2 times 0 is less than 10. 0 less than 10, that's true. So this test point was true. So that means I shade on that side because that was a true statement. Okay, let's do it again. This has an x-intercept of negative 15 divided by 5. That's negative 3. It has a y-intercept of negative 15 divided by negative 3. That's 5. There's an equal to underneath the inequality. So it's going to be a solid line. Solid. And now I'm going to shade it. 0, 0 is my test point. That is not true. But we're getting a lot of false on this one. That is false. 0 is not less than negative 15. So therefore, shade the other side. It's one or the other, right? One or the other. Okay, here's another one of those horizontal lines. Let's go where y is 4. There's an equal to underneath. So it's a solid line. Notice how its y is greater than 4. Those y values are greater than 4. So there it is. Okay, last one, standard form. X-intercept is 2 divided by 1. That's 2. The y-intercept is 2 divided by negative 1. That's negative 2. This is a dashed line because there's no equal to underneath the inequality. Test point. That is false. 0 is not greater than 2. So this was false. So that means you shade the other side. And that, my friends, is the end of that. Woo! Okay, stay strong. Be great. See you soon. Bye.